Hello there, math fans. Dr. Andy Lovelace, longtime instructor from the University of Washington, playing around with baseball geometry. I hope you've watched my previous videos where I've talked about several interesting and quirky bits of geometry. My previous video, I really talked about a practical thing from when I ran baseball leagues in terms of how do you find second base when it's buried. So check that out. That's probably the most useful of these because it's something I've used many times. Here's another one. Lining a baseball field. So if you don't know about lining a baseball field and you have kids that do baseball, you may eventually have to do this a lot. Baseball demands a lot of parents and volunteers because sometimes you have to show up, half an hour, 45 minutes, an hour early. Sometimes I'd go over earlier in the day if I could, and I would line the field and come back. It takes a bit of work and a bit of geometry to do right. Many times I would have to teach people, even people that had played baseball before, how to properly line the field. Sometimes I would show up and they would line it up incorrectly. Oftentimes you have some devices to help you with this, but I had a few comments. So youth baseball field, meaning other 12, this is like the little league layout. Now, not everyone does this little triangular piece at the back. Interestingly, even in baseball, they did that for a time, but that was before my time. The batter's box has been around for a long time, but I thought the question I'll ask you, a small question, where is this point? And where is this point? And I have a short, nice little answer. It's an opportunity for us to play around with some basic lines and intersection. And I'm going to give you an easy way to remember what that is. Now, that's not really valuable in lining a field, but it's a double check. If you knew what that was, or knew like how far away it was from the edge, you could use that as a quick eyeball of, have I really messed things up? And when you're lining a field, that's kind of nice. So there's your puzzle. If you want to pause and think about, where in the world is this point? How would you describe it to someone in a practical way to help them? If you want, you could also play the game of where in the world that point is. And where is this point? A few double checks, if you're done lining your field. Now, I can tell you that there were many times at the beginning of the season I would show up, I would tell the coaches how to line the field, and I'd come to the field and they would have drawn a chalk line from here. And they were like, uh-oh, now what do I do with the batter's box? And then they'd have to erase part of their chalk line. And they'd be like, well, where do I erase to? And it's an ordering problem. When you're doing this, you should do the batter's boxes first. Then do your chalk line. It's tough because you have to walk over it without. So let me give a little bit more about chalking, and then we'll come back and we'll do some visuals here. So just a little bit of history. The batter's box was first introduced in 1874. So it's been around for a long time. Since then, it's been 6 feet long. So things haven't changed too much. It was eventually moved to, I think it was about a foot away from the plate, and then it was moved to 6 inches. So it's been pretty much the same since about 1885, but a few adjustments along the way, but I'm going to get rid of that. So what I'd like to do is just say a few things, and then we'll eventually solve that initial problem. So a lot of the calculations have to do with the unusual nature of home plate, so we'll need some numbers from that. But if you never chalked a field before, this is typically how it goes. So sort of I just collected a bunch of pictures that some I had, some I found online. Step 1 is you hope you have this device. If you don't have this device, then you're going to want to measure a few corners from this. It's really nice to have something like this, though, that you can flip over, but you do this first. So you line it up. It depends on the device, but typically you can either use a stick or something and mark it out and then pull it away and then run the chalker over. Now, in my experience, when I chalked fields, I always had something like this. It typically didn't work. It was bumpy, the one we had. So every few feet it would clunk out, so you had to go really slow. Chalk would get stuck in it because somebody left it out in the rain. I do see some places have nicer. Now, when you watch Major League Baseball, they actually do it differently now, which I'm a little sad. But at the Mariners games up till a couple years ago, this is what they would do. Somebody would walk along with a big thing of chalk, and they'd hit both sides of it as they went. And they had this string laid out that you could watch them do it. And they would do this. So it's a very thick formal chalking. Now it's more like a spray paint stuff they use. So it's not the same. It was kind of endearing how they would walk along and beat the chalk out if you never watched before the game. So anyways, that's a thing of the past. But still, when you're out at a baseball field, you're doing this. Now, how do we do that? So first you would set this thing up. That's step one. Once you have that right, then you would set up your line. Usually the line looks something like this. And again, I was no expert when I started doing this, but I had to do it for all these games. And had to teach a bunch of people to do it. Often you don't have very good equipment. Sometimes you really need to do some math. But you set this up behind home plate. You use that 12 inches of home plate. I said before how this makes you realize that the entire baseball field is based off of 12 inches, which is crazy. And then you go find your base. You have to, dig out that base peg. You set your base down. And very important that the chalk line goes right against the edge, which is kind of awkward sometimes when you're running this thing, trying to run it over the base. I think what I used to do is I'd run it right to the base, and then I would take the base off, or I had it off already, and then I would keep running all the way to the outfield line. Usually the outfield line is painted in a solid way. I think the city would do that for us. They would spray paint it after they would cut the grass. Sometimes you have to do that part yourself. Anyways, that was the setup. But you would start chalking from the edge of here, wherever you would use that line, and you would just start wherever that edge is. So my question is sort of a double check of your line. Is where your line crosses approximately right? Now, you can eyeball this, but I'm going to give you a precise number and tell you that it's easy to remember. Now, just a small comment. A lot of times people are in a hurry and you see things like this. Like the chalk line is on the wrong side of the base. Very common that I would see people run the chalk line through the middle of the base because they misunderstood. Again, people that knew baseball. I saw all sorts of different mistakes with this over the years. So you learn. This is not something I guess you don't really learn until you're coaching, how this goes. Anyways. It's a labor of love. A lot of good ways to hurt your back. That's why after you've done all this work, your coach will yell, "Get off the field," because they don't want you to mess up the fact that they've raked the dirt, they've done the chalk line, they spent an hour on it, and then a kid comes flopping in and messes it up. It's a labor of love. All right, so let's steal home plate and solve this little problem. So I actually looked up the full dimensions, but I want to use this. Let's start with the youth sports one because that's more likely the situation you're going to be in. So there's our youth sports setup. Again, not some use of Desmos. I have decided to impose a coordinate system. That's something you get to do when you're solving a problem. So I'm going to impose a coordinate system, and I've chosen to have it be in line with those points on the base. Why did I do that? Well, there's not a right or wrong answer. I could have done it at the point, which would have made it. That's what I initially started to do, and I realized because everything on the problem is kind of based off of this point on the base home plate, I was like, I better set that as the origin because so many of the measurements are based off of that. And then after a bit of playing around, I was like, yeah, that's better. So I'm just giving the point that I didn't arrive at that first. But then I started to think, well, what can I say? And I'll just give you my first thought. It's not the best thought. I'm sure I could have drawn some triangles. There's probably some trig answer. But let's just focus on that for a second, and then we'll test things out. And please pause and try it yourself. So what I noticed is this line, because I'm not afraid of lines here, that goes from here to here. I know the slope of that line. You should think about what it is. Some would call it a 45-degree line. The slope is 1. So I'm going to get into a little bit of math here, but this is more just an exploration. It's not a big thing. I need the slope and the point. I have several other videos on lines if you want to review on that, but I know the slope is 1. The question is, what's the y-intercept? And this is where it's sort of bad that I chose the center, this point as the center, because the y-intercept of that line is not at the center. So what is it? The y-intercept is however far it is from that point. Let me zoom this up for you a little bit. Move this up. Again, I'm just doing a little exploration of some lines. So I'd like to know that distance. That distance actually is an important distance for the entire problem. It sort of makes things messier, but let's compute it. So we're going to do a little bit of trig. So we're going to draw this triangle here. It's kind of the same bit of trig over and over again on the baseball field. I'm going to call this x, this x. Now you might say, isn't that just 17 over 2? Isn't that just 8.5? I like your reasoning, but let's just do a little calculation. So this is going to be x squared plus x squared is 12 squared. So we get 2x squared is 12 squared. You might say, why am I not saying 144? Because I kind of see what's going to happen. X squared is 1/2 of 12 squared. And then I can do this square root. So I'm going to get the following. X is equal to 1 over the square root of 2 times 12. Now you never see it written that way because of this weird thing about radicals, which is you can multiply top and bottom by the square root of 2. This always, I have to take a long time in class when this happens to explain this to students. I'm not going to give you the full thing. Why do we do this? Well, it's kind of a historical piece of, it's nicer to have the square root on top for computation, but here it's really nice because you get square root of 2 times square root of 2 on the bottom. And so you get 12 over 2 square root of 2, and altogether you get 6 root 2. Now 6 root 2 is a very important number when working with home plate. It's this length. 6 square root of 2. It's also this length. 6 square root of 2. It's also this length. You say, hold on, wasn't that 8.5? Well, technically it's not 8.5. 8.5 is wrong. I mentioned that in the previous video. And this is the part that a non-math person will be like, who cares? And that's fine. You don't have to care about anything. But it isn't quite exact. It's significant enough that I'm surprised there isn't more mention of this. But this is 8.48528. And change. It's an irrational number. And I sort of wonder when they manufacture bases, they probably just use that number, is my guess. Or do they fudge on the 12? I'm not sure if they fudge on the 12 or if they fudge on the 17. I assume the 12 is kind of the standard and everything else is adjusted. But I don't know that that's right at all. Anyways, it's 8.5, but I wanted to remind. So anyways, that's the number. But I'm going to do everything exact and show you that even doing it exact, there's a certain style to solving equations where students really want to reach for a calculator, but the longer you can work exact, often the easier your life is. And again, I'm not claiming I'm doing this problem in the nicest way. I'm giving you what I originally thought. So I now know what the y-intercept is. It's down from the origin, so I'm going to call it negative 6 root 2. That's probably the hardest part of the problem, but we're through it. I want to know when that line intersects this horizontal line. Now there is one little snafu that's easy to mess up, but this is what happens in real problems. Everything I've done so far is in inches. But these numbers in my diagram are in feet. So what am I going to do? I need to go 3 feet up. What is 3 feet up? Well, it's the same as 36 inches. How did I do that? Is there going to be conversion on the test? That's what students always say. They say, how can you convert it without having a conversion calculator? I've had a lot of people get really mad at me about that. which worries me because what are you going to do when you're out on that baseball field? Say, well, I have a phone. I'll just do a conversion calculator. I'll ask someone else. Whatever. If you get your phone out, you're going to break it. That's what I have found every time I'm working on the baseball field. But anyways, you should be able to think about it. And hopefully people watching this. But a lot of students tell me they like this thing they learned, dimensional analysis. I learned that from students at the name. But we should have a sense about units. I think that the right question when someone says, are we going to have to convert, is, are you going to live in the world? You got to get used to this. But I'm done convincing people to learn anything. If you don't want to learn anything, you don't have to. But I sure like to know a few things. And this is examples of how it's helped me. Okay, this horizontal line is all the points where y is 36. And I think sometimes students miss this idea of, it's not about memorizing a bunch of equations, it's about combining conditions. So this point I'm trying to find, I don't know what we want to label it. Let's label it something. How about A, B? This idea of labeling unknowns is so fundamental. And people don't realize they can do this whenever they want. What are the conditions? Well, AB has to be on this line, and it has to be on this line. So if I put an A here, this has to be a B. And this has to also be the same B. Your goal in solving is to combine conditions. It's not to set things equal. The words set them equal often make people do the wrong things. The goal is to combine conditions. And in this case, those are the same. I want those to be the same. So it's actually substituting. So I want 36 to be this. So again, is this the best way? Probably not. But what am I getting? X is 36 plus 6 root 2. It's a very small bit of arithmetic. There's not much going on there, but I thought this still was interesting because I often see mistakes on things like that. I know what B is. It's 36. Now, if I was solving this problem, there is no way I would reach for a calculator now. That would, to me, would be a big waste because I would see how much further I can go before I do that. I imagine myself standing out on this baseball field where I don't have a calculator handy. You might say, well, how would you have dealt with the equations? That's coming. Okay, what I really wanted in this problem was some sort of point of reference. I'm just trying to make this as realistic as I can. And this is what I think about. Students are like, well, if you can just use a solver, can't you use a solver? It's the thinking that matters. The point I'm trying to make. So what I was trying to figure out is how far we are from the edge. So let's relabel and think about that. So I don't know what to call that length there. What letters haven't I used? Let's use capital A this time. There's no right or wrong here. And then let's talk about how far it is from here to here. Let's use capital B. I know capital A now. This is capital A. What's capital B? If I could figure that out, then the difference between them would be this point of reference I'm trying to figure out. And this is just a problem I made up. And as I made it up, I was like, oh, there's a cleaner answer. But I found the messy answer first, and it worked. People can solve problems like this. Notice I haven't used anything too advanced. I had to know the equation of a line to do what I did first. Okay, what do I know? I would like to do everything in inches, and I'm just going to count things up. I need to go to the edge of the base, and then I need to go 4 more inches, and then I need to go 3 more feet. So edge of the base, we already know that that's 6 root 2. This sort of geometric reasoning I have discovered is very hard for current students to do. And I would argue this is very valuable to be able to think through a diagram. You know, I think that sort of thinking, look at a schematic. Someday you may have a lot more money than me, very likely. And you're going to ask some person to do some construction and they're going to show you a design. And you may have to just label things and be able to look at it and understand it. or else you're at the mercy of someone else always. I would not like that. Okay, let's keep going. Now I want to go 3 more feet. So that's going to be 36 inches. How did I do that conversion? Again, I'm not scared of such things. If I'm always having to look for a converter, then if everything we do, we have to look something up, life becomes a lot harder. And that's what's happening for a lot of students in our math courses. So what is that? Well, that's my B. And this is probably people watching this video. This isn't helpful, but that's it. What was I looking for again? I was looking for B minus A. You can see why I held off on the calculation, because I can see they're going to cancel. And the moment I saw this, I was like, aha, what's B minus A going to be? It's just going to be 4. And then I was like, oh, there must have been a nicer answer. So if you do this minus this, it's 4. Then I was like, how can I convince myself that it's 4? If it's only 4 inches, that's kind of nice, because I could eyeball 4 inches from the edge. And that's kind of helpful. So if you're doing a youth baseball field and you draw that line, it should hit about 4 inches from the corner. Then I was like, is there a way we could remember that? Why is it 4 inches? Why is it just shifted 4 inches? And that got me thinking about shifting. And so I did the following. Let's take the Little League box and shift it over. Ready? There we go. I shifted it over 4 inches and now it's hitting the corner. And I was like, oh, I can see that. I should have seen that from the first place. And I was like, oh, I probably could have drawn a little triangle to do that. And then I'm like, okay, now I'm never going to forget it. I shifted over 4 inches. It's going to be the same. Why is that? Well, because the slope of that line is 1. And so if you shift it over 4 inches, the amount you're going to go over is the same amount as you're going to go down. So I should have had this ready. I'll do a quick little screenshot so I can show you what I'm thinking. So what I'm saying here is that because the slope is 1, however far you go over is the same amount you're going to go down. So that tells me, since it's 3 feet up and it's 3 feet over for the batter's box, that tells me it's going to hit the corner. So if you shift it over 4, it's going to hit the corner, which means it's 4 inches. And I was like, oh. So I didn't know where this was going to go. I just knew I wanted to talk about lining the field. And I thought, oh, that's kind of nice. So there you go. There's your answer. The actual point that I originally asked is that point. But the rule of thumb is 4 inches. It's just 4 inches from here to here. I never really thought about that. Now I'll never forget it. And it's a nice little eyeball. Okay. So then you might say, well, what about on Major League Baseball field? It's certainly not 4 inches. It looks quite a bit bigger. But I was like, well, I know how much I can just shift a little more. But anyways, I'll kind of leave that as an exercise for you. Now, the difference in a Major League Baseball field is that's 6 inches. So you might have to think about what happens. What if I shift it over 6 inches? I won't quite be there because it's a foot longer. So I'll leave you to kind of think about that. The only other things I was going to say, but maybe that's enough. I feel like I've been talking too long. But you could now, if you want, do a little exercise of figuring out where this is. Now, unfortunately, this isn't quite as nice. I have all those labeled here. I did figure out where those were and where they would be. And then same thing for this. Okay, I think I will leave that, but some things to think about. Think about what your other questions might be. But mostly that was kind of an exercise in thought process and how what I think is valuable about mathematical thinking. Labeling unknowns, checking your work, not getting stuck relying on some sort of calculator or converter, not because I'm against those things, but because I think they hurt my ability to think. If I'm having to stop and do those things all the time, it just slows me down. They're hindrances. So whenever you are working questions, doing homework, it's really hard now in the modern world, but you have to try to practice doing some calculation, or else you're too slow to do real problems. And you're going to be out on a baseball field and you're not going to be able to figure things out because you're going to have to look something up. It's going to take too long. These are examples from my life that have been helpful. That many people, this is one of those places where I actually know something that helps people. It doesn't make me any money, but it certainly makes it so it's easier for me to do just some everyday things. All right, hope you find that interesting.